Hey everyone, welcome back to the channel. Today we're going to simplify things with the Facade Design Pattern in Python. If you've ever dealt with a complex system and wished for an easier way to interact with it, the Facade Pattern is just what you need. I'll break down how this pattern works, why it's useful, and how you can use it to streamline interactions with complicated systems in Python. Let's get started. 1. Introduction. The Facade Design Pattern simplifies how clients interact with a complex system by providing a streamlined interface. Instead of dealing with multiple subsystems, the Facade acts as a single point of access, making it easier for clients to work with the system without needing to understand its complexities. This design pattern helps manage complexity by hiding the detailed workings of the system, offering a user-friendly entry point for clients to perform their tasks more efficiently. Key characteristics. The Facade pattern simplifies complex systems by providing a high-level interface, making it easier for clients to interact with multiple subsystems. It hides the underlying complexity of these subsystems, offering a more streamlined experience. By decoupling the client from the internal workings of the system, the pattern promotes flexibility and easier maintenance. It also provides a single access point, reducing the learning curve and allowing clients to focus on functionality without worrying about how the subsystems work. 2. What is the Facade Design Pattern? The Facade Design Pattern offers a streamlined interface to a complicated system, allowing clients to interact more easily with various subsystems. It hides the system's complexity and provides a clean, user-friendly interface, ensuring the system's functionality remains intact. This way, clients can perform tasks without needing to understand the intricate details of how everything works underneath. Real-world analogy. Imagine a universal remote control that replaces multiple remotes for your TV, sound system, and Blu-ray player. Instead of handling each device separately, the facade simplifies the process by offering straightforward buttons for control. Behind these buttons lies the complex logic for managing each device, but the user only interacts with the easy-to-use interface. This allows the user to control all devices seamlessly without dealing with the complexity of individual remotes or commands. 3. Why use the Facade design pattern? The Facade design pattern is ideal when a system has many complex subsystems or libraries and clients need a simpler way to interact with them. By offering a single easy-to-use interface, the pattern hides the internal complexity, providing a cleaner way to access the functionality. This helps reduce dependencies between the client and the subsystems, making the system more readable, usable, and modular. It also promotes loose coupling, allowing the client to remain unaware of how subsystems work, making maintenance and future enhancements easier. 4. How to implement the Facade design pattern in Python. The Facade design pattern simplifies interaction with complex systems by providing a unified, easy-to-use interface. Instead of dealing with multiple components, clients interact with a single facade that handles the complexity for them. This pattern hides the system's internal workings, reducing the learning curve and allowing clients to focus on high-level operations without worrying about the details. By implementing the Facade pattern in Python, you can streamline code interactions, making systems more manageable and user-friendly. Step-by-step implementation. In this example, we are demonstrating the Facade design pattern, which simplifies interactions with complex subsystems by providing a unified, easy-to-use interface. Here, the system consists of three subsystems: order system, payment system, and shipping system. Each of these subsystems handles specific responsibilities within an online store. The order system is responsible for managing product orders, the payment system handles payment processing, and the shipping system arranges shipment for orders. Individually, these subsystems work fine, but from the client's perspective, interacting with each subsystem separately can be cumbersome and complicated. This is where the online store Facade class comes into play. The online store Facade acts as a simplified interface that allows the client or user to interact with these subsystems as if they were a single unit. It abstracts away the complexity of each subsystem and combines their functionality into a single method, complete_order. In the complete_order method, the facade coordinates the entire process of placing an order. It first calls the place_order method from the order system to place the order. then processes the payment using make underscore payment from the payment system, and finally arranges the shipping with arrange underscore shipping from the shipping system. The client only has to call the complete underscore order method with the necessary parameters like product ID, quantity, and payment amount, and the facade handles all the details behind the scenes. The result of each subsystem's operation is returned as a combined string that shows the status of the order, payment, and shipment. This design makes the system much more user-friendly by hiding the complexities of managing orders, payments, and shipments. The client doesn't need to know how each subsystem works, they only interact with the facade, which makes the whole process simple and efficient. This pattern is commonly used in systems where you have multiple subsystems working together and you want to provide a simplified interface for the end user. 5. Real world use case Facade Design Pattern in action. 1. Home automation system. In a smart home system, various devices like lights, thermostats, cameras, and locks need to be managed efficiently. The Facade pattern simplifies the control of these devices by providing a unified interface, so users can manage everything from one central point without dealing with the complexity of each individual device. This makes it easier to interact with the system, ensuring smooth and consistent control over the entire smart home. Why Facade pattern? The Facade pattern simplifies interactions by hiding the complexity of dealing with multiple device APIs behind a single, unified interface. It allows users to perform actions without worrying about the underlying details, making the system more user friendly. By centralizing control logic, the Facade pattern makes the system easier to manage and extend, especially when new devices are introduced. This approach ensures that changes or additions can be made without affecting the user experience or requiring significant changes in the core logic. Expanded use case. Imagine a home automation system where users control smart devices like lights, thermostats, and cameras with simple commands like leave underscore home or arrive underscore home. Instead of managing each device's interface, the Facade pattern simplifies everything. For example, when user selects leave underscore home, the system turns off lights, lowers the thermostat, activates cameras, and locks doors. Similarly, selecting arrive underscore home turns on lights, adjusts the temperature, and unlocks the doors. The Facade makes the entire system easier to use, and if new devices like smart blinds are added, the Facade can be extended without changing the core code. Practical implementation. In this example, we implement the Facade design pattern to simplify the interaction with various subsystems in a home automation scenario. The system consists of several independent subsystems like thermostat, camera, and door lock, each responsible for handling specific actions. For instance, the light class manages turning lights on and off, the thermostat class adjusts the temperature, the camera class activates or deactivates security cameras, and the door lock class locks or unlocks the doors. Without the facade, a client user would need to interact with each of these subsystems individually, which can be cumbersome, especially when trying to perform routine tasks like leaving or arriving home. This is where the home automation facade class comes into play. The facade provides a simplified high-level interface to perform these tasks in a single method call. For example, when leaving home, the leave underscore home method turns off the lights, sets the thermostat to an energy saving temperature, activates the security cameras, and locks the doors all through one method. Similarly, the arrive underscore home method reverses these actions by turning on the lights, setting a comfortable temperature, deactivating the cameras, and unlocking the doors. By encapsulating the complexity of interacting with multiple subsystems, the facade pattern makes the client's experience much smoother and more intuitive. The client doesn't need to know the details of how each subsystem works or how they interact. They simply use the home automation facade and the facade handles the rest, orchestrating the actions of the subsystems behind the scenes. This approach leads to cleaner, more maintainable code and makes the system more user-friendly by abstracting away the intricacies of the underlying components. 2. Unified API for third-party services. In applications that work with multiple third-party services like payment gateways or cloud storage, the Facade pattern simplifies integration by offering a unified API. Instead of dealing with different interfaces and complexities for each service, the Facade acts as a single point of access. This makes it easier to manage the interactions and keeps the application code clean and consistent when switching between surfaces or adding new ones. It improves maintainability while hiding the complexities of individual services. Why Facade Pattern? The Facade Pattern simplifies the complexity of working with different third-party APIs by offering a single unified interface. It ensures that the application doesn't need to handle the intricate details of each API, making it easier to switch or add new services without modifying the core logic. This approach helps keep the system more modular and maintainable, allowing for quick changes or extensions without disrupting the existing functionality. Expanded use case. Use Imagine an online e-commerce platform that needs to support multiple payment options like PayPal, SafePay, and Square. Instead of interacting with each payment gateway directly, the platform can use the Facade pattern to create a unified payment facade. This facade simplifies payment processing by allowing the application to call a single process payment method, hiding the complexities of different gateways. Adding new payment services like Apple Pay becomes easy as the facade pattern abstracts the third-party service interactions, enabling seamless integration without disrupting the core logic. Practical implementation. In this example, we are using the Facade design pattern to simplify interactions with multiple payment gateways including PayPal, Stripe, and Square. Each payment gateway is represented by a subsystem class PayPal, Stripe, and Square, each of which has its own method for processing payments. Individually, these classes allow for payment processing through their respective platforms, but managing interactions with each one separately can be complex, especially if a system needs to support multiple gateways. The payment facade class acts as a simplified interface or facade that abstracts away the complexities of working with these individual gateways. Instead of the client needing to know how each gateway works and interact with them directly, the payment facade provides a single method process underscore payment, which allows the client to specify the payment gateway and amount. The facade internally handles routing the request to the correct payment gateway, making it much easier for the client to work with. If a client wants to make a payment using PayPal, Stripe, or Square, they simply call process underscore payment with the appropriate gateway name and amount, and the facade takes care of calling the correct subsystem class. This design improves code maintainability and flexibility. If the system needs to add support for another payment gateway in the future, the developer can add a new subsystem class for that gateway and extend the facade without changing the client code. This pattern is beneficial when dealing with systems that have multiple components or subsystems, as it reduces complexity for the client and centralizes the logic for managing interactions with those subsystems. 3. Complex video streaming system. In a video streaming platform, handling operations like encoding, buffering, and playing media files can be complex. The Facade pattern simplifies this process by offering a single, user-friendly interface that manages video playback. It hides the intricate details of encoding and buffering, allowing users to focus on enjoying the video without worrying about the underlying technology. This pattern ensures that the platform remains easy to use while managing the complex tasks behind the scenes efficiently. Why Facade pattern? The Facade pattern simplifies complex systems by providing a unified interface, allowing developers to interact with the system without worrying about its internal complexity. It improves maintainability by hiding the intricate details of video processing operations, enabling developers to focus on higher level tasks. By encapsulating these operations within the facade, the system becomes easier to manage, making updates or changes more streamlined without exposing the underlying processes. Expanded use case. Say, imagine a video streaming platform like Netflix or YouTube where users expect seamless video playback without dealing with technical complexities. The facade pattern can be applied through a video play facade, providing simple controls like play, pause, and stop to manage playback. This facade hides the internal complexities like encoding, buffering, and decoding, making it easy for developers to integrate video streaming features. If a new video format or buffering method is added, minimal changes are needed as the facade pattern encapsulates and manages the internal video processing logic. Practical implementation. In this example, we demonstrate the Facade design pattern by simplifying the process of video playback, which involves several complex steps like encoding, buffering, and playing the video. We have three subsystem classes: video encoder, video buffer, and video player. Each class handles a specific task. The video encoder is responsible for encoding the video file. The video buffer handles buffering the video to ensure smooth playback. And the video player manages the actual playback of the video file. Individually, each of these steps is necessary for video playback, but they add complexity if the client has to manage all of them directly. The video player facade class acts as a facade, combining these steps into a single simplified interface. Instead of the client needing to call the encoding, buffering, and playback steps separately, the facade provides a single play underscore video method that handles the entire process internally. The client simply provides the video file name, e.g. movie.mem4, and the facade manages the interaction between the encoder, buffer, and player behind the scenes. Additionally, the facade provides methods like pause underscore video and stop underscore video, further simplifying the video control process for the client. This approach makes the system much more user friendly and abstracts away the complexity of dealing with multiple subsystems. The client interacts only with the facade, allowing them to perform complex tasks like video playback without worrying about the underlying details. This makes the code easier to maintain and extend, and if the internal implementation of encoding, buffering, or playback changes, the client code remains unaffected. This is a key benefit of the Facade design pattern. It reduces complexity and creates a cleaner, more intuitive interface for users. 4. Travel booking system. In an online travel booking platform, users often need to book flights, hotels, and car rentals together. The Facade pattern simplifies this by providing a single interface that coordinates all these services behind the scenes. Instead of interacting with each service separately, the Facade pattern lets the user make all bookings through a unified interface, streamlining the process. This way, even if the underlying systems are complex, the user only sees a simple, straightforward interface, making the booking experience seamless and efficient. Why Facade pattern? The Facade pattern simplifies the user experience by offering a single interface to handle complex tasks like booking flights, hotels, and car rentals. It shields users from the intricacies of interacting with multiple service providers, making the system easier to use and manage. By decoupling the system from these complexities, it allows for smoother interactions and a more streamlined process, ensuring users don't get overwhelmed by the details. Expanded use case. Imagine an online travel platform where users can book a complete vacation package, flights, hotels, and car rentals all from one interface. The Facade pattern simplifies this process by hiding the complexity of dealing with multiple services. For instance, the travel booking facade class offers a straightforward method like book complete trip, which coordinates flight bookings, hotel reservations, and car rentals behind the scenes. This allows users to easily plan their trips without navigating the complexities of each individual service. Practical implementation. In this example, we implement the Facade design pattern to streamline the process of booking an entire trip, which involves coordinating between multiple subsystems such as flights, hotels, and car rentals. Each subsystem class flight booking, hotel booking, and car rental booking is responsible for handling its own specific task. The flight booking class books flights to the desired destination, hotel booking manages hotel reservations, and car rental booking handles car rentals. Individually, these classes allow you to book each component of a trip, but the process can become cumbersome if the client has to interact with each subsystem separately. The travel booking facade class serves as the facade, providing a simple interface that abstracts away the complexities of interacting with these individual systems. Instead of requiring the client to manually call each booking method, flight, hotel, and car rental, the facade consolidates everything into a single method: book underscore complete underscore trip. This method takes the destination as an input and in the background books the flight, hotel, and car rental by calling the appropriate methods from each subsystem. The client only needs to make one call to book underscore complete underscore trip, and the facade manages the entire trip booking process. This design significantly improves the user experience by reducing the complexity of managing multiple services. The facade simplifies the interaction, allowing the client to focus on their objective, booking a complete trip without needing to worry about the underlying details of how each booking is made. Additionally, this approach makes the system easier to maintain and extend, as changes to any individual subsystem, like adding a new booking service, can be handled within the facade without affecting the client code. The Facade Design Pattern thus provides a more efficient, cohesive way to manage complex interactions between multiple subsystems. 5. Cross-platform game development. In cross-platform game development, different platforms like PC, Xbox, and PlayStation often require distinct implementations for graphics, sound, and controls. The Facade pattern simplifies this by offering a unified interface that hides the complexities of each platform's specific API. Instead of the game needing to manage multiple platform-specific APIs directly, the Facade handles the interaction, allowing the core game logic to remain clean and platform independent. This makes it easier to switch or add platforms without significantly altering the game's architecture. Why Facade pattern? The Facade pattern abstracts the complex platform-specific details, enabling the game code to stay consistent across the multiple platforms. It simplifies adapting the game to new platforms by centralizing all platform-specific logic in the facade, ensuring that the core game logic remains unchanged. This allows for easier maintenance and scalability, making the integration of new platforms smooth and efficient. Expanded use case. Imagine a game development scenario where the game must run on multiple platforms like PC, Xbox, and PlayStation. Using the Facade pattern, a game engine Facade provides simplified methods such as render scene and play sound, which internally manage platform-specific differences. This way, game developers can focus on core game logic without writing platform-specific code for every function. If a new platform like mobile is introduced, the Facade can be extended to support it, ensuring the game logic stays consistent while handling platform variations smoothly. Practical implementation. In this example, we are implementing the Facade design pattern to simplify the process of cross-platform game development. The challenge with developing games for multiple platforms such as PC, Xbox, and PlayStation is that each platform has its own system for handling graphics, rendering, and sound playback. This requires developers to write separate code for each platform's specific needs. Here, the PC graphics, Xbox graphics, and PlayStation graphics classes handle graphics rendering for their respective platforms, while the PC sound, Xbox sound, and PlayStation sound classes manage sound playback. The Game Engine Facade class acts as the facade that abstracts away the complexities of handling different platform-specific systems. Instead of having to manually initialize and manage each subsystem for graphics and sound on different platforms, the Facade provides a unified interface. When the client game developer specifies a platform like PC or Xbox, the Facade initializes the correct subsystems internally. The client can then call high-level methods like render underscore scene to render graphics and play underscore game underscore sound to play sound. And the Facade takes care of executing these tasks using the platform-specific subsystems. This design significantly reduces complexity for the client by hiding the details of platform-specific implementations. The client can simply focus on calling the facade's methods without worrying about the underlying system differences between PC, Xbox, and PlayStation. Moreover, the facade improves code maintainability and scalability. If additional platforms or new functionalities are introduced, they can be handled within the facade without altering the client's interaction. The facade design pattern here ensures that cross-platform game development is efficient, modular, and easy to manage. And that's it for the Facade design pattern. I hope this video helped you see how you can simplify your code and make complex systems more manageable with this pattern. If you enjoyed this tutorial or learned something new, make sure to like and subscribe for more design pattern videos in Python. Thanks for watching, and I'll see you in the next one.